So, I talked last week about the fact that we have 3 different types of minerals that are very important in signal transmission in a neuron, when a neuron transmits a signal. They were sodium, potassium, and calcium. We saw that there were voltage-gated sodium receptors and voltage-gated potassium receptors along the axon of a neuron and at the axon hillock. There were actually many at the axon hillock. That's the zone of summation. And at the axon terminal, the axon bouton, the axon ending, there are also a lot of voltage-gated mineral channels. These are called voltage-gated calcium channels, And they are specifically designed to allow calcium to come into the cell, okay? So when the action potential here comes down the axon to the axon terminal, it's going to open up these voltage-gated calcium channels, which is going to cause calcium to rush in to the axonal ending. It's going to cause calcium to rush into the bottom of the cell, which is going to help release these organelles, these little things called synaptic vesicles. Vesicle. It's going to help them to release synaptic vesicles. Okay, so calcium is going to flood into the cell, and through a certain biochemical mechanism, calcium is going to help these vesicles to release. So they're kind of sitting up there waiting to be released. They're these kind of like membranes. There are these kind of like sections of membrane. Just like inside a cell, you have those organelles, like the vacuoles. Remember you learned about that? And the organelles are kind of covered with the phospholipid membrane. You remember learning about that? These are sections of membrane that contain neurotransmitters. These are sections of membrane that contain neurotransmitters. They are like little packages filled with neurotransmitters. Neurotransmitters are created, they're manufactured, they're made in the cell body, they're made extracellularly, they're made from components outside the cell, but they're made in the cell body. They're then transported down the axon, inside the axon, right? So inside the axon, these packages of neurotransmitters are kind of sent down to the axon terminal where they wait to be released. They wait to be released. You could see that. I have a slide on that, and also that's going to be in your textbook as well. So they wait to be released. Once calcium comes in, calcium is going to tell those little packages of neurotransmitters to drop. They're going to drop, and they're going to kind of hang out at that presynaptic membrane. Okay, they're going to hang out at that presynaptic membrane. So if we go over here and we look at this, we're going to see right here is the synaptic vesicle. The synaptic vesicle was up here. Calcium came in, causing it to drop, and then it's going to go here. Now, what happens, and eventually it's going to release its contents, okay? It's going to release the contents across the synaptic cleft. Now, what happens is this. The synaptic vesicle has to meet or has to tie to a docking protein. It's like a dock. It's like a ship ship comes into a dock, right? Or ship goes into a harbor and it docks somewhere, right? It either puts its anchors down or it ties itself up to a dock. You all know what I'm talking about? Okay, when you have a ship, like let's say you have a tiny little, just a little, whatever, rowboat, and you row it across the lake. When you come to the pier, you have to tie it up, right? So you have to dock it, you have to anchor it. Or if you have a big ship, like my yacht, that you're all invited, no. No, you're not invited to my yacht. I don't bring students on my yacht. I'm sorry, it's my yacht. I'm not invited to your yacht? Okay. Let's have a yacht party. We'll just like not invite each other to we'll just take over Manhattan with our yacht parties. Okay. Okay. So it has to dock. So the synaptic vesicle has to so it drops and then it docks. It kind of like, where am I? Where do I look? Okay, here's a docking protein. Boom. The docking protein is going to help So it's going to connect, the docking protein is lodged on that presynaptic membrane. It's going to dock to the docking protein. The docking protein is going to connect the synaptic vesicle with the presynaptic membrane, and then it's going to help to open it up. So the docking protein is going to help to open up that vesicle, and then the vesicle is going to dump its contents out into the synaptic cleft. And that is how a signal is transmitted at the chemical level. So we talked about electrochemical signal transmission. This signal, the way that a neuron transmits a signal is both electrical and chemical. You need both. Okay, so there is an electrical part of the transmission, that is the signal going down the axon to the axon terminal. That's electrical. We learned about that last week. You have the resting potential, -70, right? Which then, once that's triggered at around 55, -55, you go up to electrotonic potential, right? So that's action potential. That's triggered. Once that starts, that doesn't stop. Then you have the combination of action potential and electrotonic potential in saltatory conduction. Okay? That whole process of resting potential going to action potential, and then the combination of action potential and electrotonic potential transmitting a signal on a covered axon or a partially covered axon. That's all electrical. Are you all with me there? Okay, any questions? So you all understand all those concepts? Wait, then why don't you have questions? I'm serious. What, you all understand what action potential is? You all understand what resting potential is? Okay? You all understand that the cell has a resting potential of about -70, yes? You all understand electrotonic potential, yes? Who doesn't? Who doesn't? So do you all understand electrotonic potential? I don't want kind of. Ask a question, yeah. Kind of. You don't understand it. Okay, good. Electrotonic potential is the change in tonicity. Remember that every mineral has a charge. So sodium, potassium have positive charges. So if sodium floods into the cell, the inside of the cell is going to become more positive. Sodium is going to flood into the cell and very quickly spread out. So those positive charges are going to come into the cell and very quickly spread. That is electrotonic potential. Okay? It's fast. Electrotonic potential is very fast. And it's very effective, it's very quick, but it spreads out kind of generally. Okay, action potential moves the signal forward. So in saltatory conduction, remember that saltatory conduction only happens on axons that are what? Myelinated, good. So only happens on axons that are myelinated. Where does electrotonic potential happen? In the process of saltatory conduction? Where does it happen? Where does electrotonic potential happen? Where does action potential happen? So electrotonic potential happens under the myelin sheath. And action potential happens where? At the uncovered parts of myelin. And what do you call the uncovered parts of myelin? You're going to be doctors and nurses in this room. Come on, do it. Say it loud. Say it proud. The what? The node of Ranvier. Good. Oh, I haven't taught you guys doctor voice. In this class, we have doctor voice. So if we're all on like one of those awful like shows, like not awful, but they're good, like Grey's Anatomy or Nurse Jackie, very different shows, right? Nurse Jackie's for like the people that have been in healthcare for a while. The ones who are kind of hopeful and want to go to medical school, watch Grey's Anatomy. But if you're in healthcare, you're like, screw that, I'm watching Nurse Jackie. But you know, like when a patient's dying, go, scalpel, nurse, pass it. That's how you have to talk in this class, because you're all going to be OTs, PTs, NPs, right? You're in like 3 to 5 years, like people's lives are in your hands. I'm not joking. That's the truth. Isn't that right? Yeah, right. Okay, so what? Like I need a big jump. So in 3 to 5 years, lives are going to be in your hands. I can't have somebody going, okay? I want nurse. What do I need? Scalpel. Okay, so we have doctor voice in this class. That's how we talk in this class. Okay, so what are the unmyelinated parts of the myelinated nerve called? What are they called? I don't have a doctor in this class. I want the doctor, I want a nurse practitioner to speak up. Come on, say it. Say it. What do they call them? With confidence. Perfect. Yes. Good. Good. You got it. Good. Yeah. No, this is kind of, I'm being a little facetious, but this is how we train people to speak up. You have to speak